Hello, welcome to ERTH413 Geological Data Analysis. I'm Garrett Apuzen-Ito, and you've joined us for week 3, which is a basic introduction to statistics. This series of videos will go through section 1.5 of Paul Wessel's notes. And you should read 1.5 to supplement these videos. So we've already talked about population versus sample. Again, a population is the set of all possible observations, or it's the complete sample space. And as we discussed, it can be finite or infinite. A sample, in contrast, is a subset of the population. It's the part that we measure or observe. And so the study, statistics, the discipline of statistics, can be described basically as how to take samples and use the properties of the samples to gain insight into the characteristics of the population. So populations have characteristics. And we'll formally describe those as parameters. And the parallel characteristics of samples are called statistics. Samples have characteristics, and they're called statistics. So let's look at some examples of some parameters and statistics. So the first example is some measure of the central value or central location of the population. And an obvious measure of the central value is the mean. And the mean of a sample which will denote, sorry about that, we'll denote that as X with a bar over it. X bar is just the geometric mean of the sample. So we sum all the values of the sample and then divide by the number in the sample. So this is the sample mean. And the population mean, we'll denote that as mu. We'll use Greek letters when describing parameters of the population and normal letters for describing statistics. And we'll use capital N for the number in the population. And again, we have to sum all the values in the population of the quantity X. And this is the population mean. Okay, so as described on page 21, the mean has numerous advantages. It's quite intuitive, it's relatively simple, and well, it's used commonly. Sometimes it's called average, but in statistics, let's formally call this the mean. Okay, so an alternative is the median. Now, one of the disadvantages of the mean is that it's sensitive to outliers. So if there's some values of x that are very different from the rest of the values, then that outlier will have a significant weight on the value of the mean. And a median is a way that is less sensitive to those outliers. So we'll denote the median as x with a tilde over it. And the way we compute the median is we sort all values from smallest to largest. So for xi, I goes from 1 to n, and x1 is the smallest, x little n, because we're dealing with the sample, is the largest. And in that case, the sample median is equal to the middle value of the sorted array, and the middle value is 1 minus n minus 1 over 2 plus 1. That is, if n is odd, okay, or if n is even, it's half the two middle values, or the two values on either side of the exact middle, I guess. And the script that I gave you, the free mat script or the MATLAB script called median that I gave you during the first class, shows you how this is done. So the median separates the lower half of all the values in the sample with the upper half. So let's consider a sample of densities of sandstone. And these values are 2.30, not 2.23, 2.30, 2.20, 2.35, 2.25, 2.30, 23.0, and 2.25. And if we take the mean of that sample, we would get 5.24. These are grams per cubic centimeters. And the median would equal 2.3. So you can see how if we have an outlier, which we do in this example, that makes the mean go to a relatively high number compared to the median. So we've looked at two ways of looking at the center value. Let's look at the final way, and that's the mode. And we'll define the mode as x with a caret over it. And if we look at, basically the mode is the most frequent value. Okay, so if we were to show some example probability distribution of a sample, or a population for that matter. So this is number of points. This is proportional to a probability distribution. It's a frequency distribution. And I'm going to draw a frequency distribution that's a little bit asymmetric. So the mode would be the value that has the highest frequency. Okay. And in this example, the mean would be someplace out here, and the median would be someplace in here. So these three measurements are slightly different. Again, the mode tells you the most frequent location. One simple way of understanding what the mean does, if we were to draw this frequency distribution, the mean tells you the centroid location. So the centroid, or the center of mass. So I'm going to draw our frequency distribution on a balanced beam. And to denote x bar, so x bar is the centroid. Okay, it describes the centroid of the distribution. And then the median, again, divides the population into two halves. So there's 50% of the values lie less than the median, and 50% of the values lie more to the median. So so in this frequency distribution plot, the area under the curve would be equal to the left of the median and to the right of the median. Now, one advantage of a mean is that we can consider we can use it to measure the central point if some data values have more importance than others. In this case, we can produce a weighted mean by weighting each term in our sum. So W is the weight for the ith term, ith value, okay, and multiplying each value by its weight, and then dividing by the sum of all the weights is a way of producing a weighted mean. And one example of a weighted mean is a way of producing a grand mean. And the grand mean, for example, if we had m samples, we could calculate the grand mean if we sum all the means of each individual sample. Where the weight is the size of each sample. So if we sampled our population m times, this gives the grand mean of all of our samples, and it's a weighted mean.